Yes, students, how are you all? I hope you are all fine. Very good afternoon. So let us move into our topic, that is yesterday we were discussing about this. What is it? Centrifugal acceleration. Acceleration. Now, so this is indicated by AC. So here, what we have to know. Okay. All right. So when an object is performing circular motion, an object is performing circular motion. So when an object is performing circular motion, the forces that exist here. So one is towards the center. So this is centrifugal. So towards the center. Right. So here, if any object is in a circular motion, whether it is uniform or non-uniform also. Okay, so what are the forces that are existing? So once an object starts to move in a circular path, even if not only it is a circular path, just if you negotiate a curve also, okay, you are going on a bicycle. Suppose you are going on a bicycle. Okay. From here and here. So this is your bicycle. Is it appearing like a bicycle? Right. So little bit I have improved in drawing. Right. So when you are moving in a bicycle, so this is a bicycle. So you are moving like this. So when you are turning here, you are encountering. That means this part is coming into the circular or this rotatory or circular motion, or this is we can consider an imaginary. That means if you complete the curve, you get a circle. So you are into the circular motion. You are into the circular motion here. So as soon as what happens is when you are riding, when you negotiate a curve, even if it is a bike or a bicycle. So what happens? You will lean inward. You will lean inward for what purpose? To get the necessary centripetal force. To get the necessary centripetal force. Otherwise, what happens? You will fall away like this. That means, if you imagine this as a circle, this part of your journey, you are leaning inward. you are leaning inward, automatically it will happen, of course. It will happen automatically, so that you are doing that act so as to provide the centripetal force by yourself. You yourself are providing the necessary centripetal force for your negotiation of the curve in order to not to fall away. Not to fall away. So this force, because see, actually this is the real force, but this is what, this is pseudo force. Pseudo force means actually, I think in motion I have told, single force never exists. Single force never exists. Single force never exists. Okay. So to balance this one, okay, we imagine ourselves a force which is exactly equal in magnitude but opposite in direction to the centripetal force, which acts away from the center. Just remember the solutions chapter. Solutions chapter. How do you separate the mixture? Suppose when you are churning the curd, okay, churning the curd, the molecules which are heavier or lighter in weight, they get away from the center of the vessel. No? They get away from the center of the vessel. So other example also, so that what you call, it is due to what force? Centrifugal force there actually. There the cream is getting separated from the center and it is moving towards the edge of that vessel. It is moving towards the edge of that vessel. Okay. So it is happening due to what force? It is due to the pseudo force, that is the centrifugal force. Centrifugal force. So what is the centrifugal force? It is an imaginary force which balances the centripetal force, which is exactly in magnitude, equal in magnitude, but opposite in direction. Opposite in direction. Okay. So if centripetal force is the force which we say that as directed towards the center of the circle, centripetal force means the force which is directed towards the center of the circle is called as centripetal force. That means for an object which is in circular motion. Then exactly opposite means what? Here we are saying that centripetal force is the force which is acting towards the center, and centrifugal force will be the force which is acting away from the center. Away from the center. That's all. So number of examples you can quote for centrifugal force, even if it is a pseudo force. It is actually, why we are calling it a pseudo force? It itself is not existing independently. Pseudo force here, see what you want to listen is centrifugal force. Centrifugal force does not exist independently. Means here we have the basic forces, no, like electromagnetic force, gravitation force, like that, etc. So this centripetal force is there. Centripetal force is a real force because it is having, that means centripetal force of why it is existing. The mass, that means an object which has a particular mass and speed is moving in a circular path. Okay, the object is real here. Mass is real, speed is real, everything is real. So this real object, when it is performing a circular motion with a particular speed, okay, this force is generated. That means acceleration is generated, so that is directed towards the center. So this is the real force because it is existing due to a activity of the real object. So, but we are experiencing some outward force also. Just imagine when you are sitting on a toy helicopter in a fair. Suppose nowadays I think it is not coming. Okay, or you sit in a wheel which is rotating in a horizontal circle. Suppose somewhere some fairs are somewhere. Okay, during festivals or sometimes. Okay, these fairs are coming up. So these toy cars or toy helicopters will be there. So just if you sit in them and if it is moving in a circular path like this, you feel to be falling away like this. You feel because if it is moving like this, okay, you feel that as if you are thrown away from that place, from the seat, okay, or from the toy car. Yes, sir. Right. So that is one example. Even when you are traveling in a bus or a car or some vehicle also, mostly bus or car like that. So when the bus or car, it is negotiating in the circle. Already we have discussed this one during this motion chapter, and that is inertia of direction. Inertia of direction. There the topic was inertia of direction, but now it is we are discussing on the centrifugal force. Of course, even there also the reason is centrifugal force only. Even there also the reason is centrifugal force only. But as we did not discuss about force there, only we spoke about inertia. That's all. Okay, but here what we are speaking, as we are speaking about centrifugal force. So when you are negotiating a curve, means the circle is like this, you tend to fall away. You are negotiating like this, you will feel to fall away like this. So when you are sitting like this and the car or bus is negotiating a curve, what happens? You feel like falling away. So what? You will hold that particular pillar or something which is there or the hand support in the car or the bus. Okay, like this, so that you will be not falling away. You will be not falling away. So here, what is this? The circle is like this. Okay, and you are falling away means something is making you to fall away. To fall away from the center. If you imagine a circular path from the circle. So a force is acting. So how it is generated now? It is actually a pseudo force. Means a force which generates or which comes into existence when centripetal force is there. Surely centripetal force will exist. So in order to balance this mathematically, we imagine a force and what we are experiencing while negotiating a car, whether it is a toy car or a toy helicopter or a real car when you are traveling or a bus. Okay, so when the bus is negotiating, just you can imagine when you are going in a bus into this Tirumala hills, because the road is having many turns, no? So when it is turning, okay, when it is turning, either if the curve is like this, you tend to fall like this. If the curve is like this, you tend to fall like this. So this tendency of what we feel like falling away from the center, we call it as, it is due to what? It is due to centrifugal force. Centrifugal force. So that's the reason why here, okay, another example also I'll say in the washing machine. If it is automatic washing machine, so after the washing is over, okay, to remove the water molecules from the clothes, what happens? It rotates very fast, dryer. So it rotates very fast such that it is having tiny holes, small holes within itself, so that when during its rotation, due to the centrifugal force, the water molecules are thrown away from the cloth. Water molecules are removed, pushed away from the cloth, so that the cloth gets dry, little bit dry. Okay, so this is another example. So like this, number of examples are there for telling for the existence of this. What is that? Centrifugal force. But our topic is not centrifugal, but you have to understand regarding this centrifugal force also. So here, what are the two forces? Okay. Hereafter, what you have to remember is whenever an object is coming into circular motion, surely two forces exist because one has to balance the other. See, why I am saying is, suppose forces are not do not occur individually. That means single force does not occur individually. I am saying, no. So I tell you one another example. In your last year or even this year also. Okay, last year you would have studied regarding the force. So suppose if there is a surface here like this. Okay, this is a surface. If an object is present here on this. Okay, some block, wooden block. Okay, wooden block. Okay, now what are the forces acting on this? Means what will you say? One force is its weight, which is equal to m into g, mass into acceleration into gravity, w, downwards, and then the other force is exactly acting perpendicular to the force which is perpendicular to the surface. Perpendicular to the surface in the above direction, which is called as normal force. What is this? Normal force. So now as these two are equal in magnitude, as this weight and normal force are equal in magnitude and opposite in direction, they cancel each other so that the object is stable. So so that the object is stable. Otherwise, what happens? If this force is dominating, the object should fly. That means it has to move in this direction. Yes or no? So, as it is not happening, we say that these two forces are equal in magnitude but opposite in direction. So, the wooden block is there in its place itself. So, like this. So, this is that means here what is happening? Forces pairs are occurring. Yes or no? Suppose if you have an applied force here, okay, you are trying to pull it in one direction, then there is another force immediately coming into existence. That is what is the frictional force. What is that frictional force? Exactly in the opposite direction. So if you try to pull in this direction, friction will be in this direction. So who has changed the direction of the frictional force? Nobody changed. So that we call frictional force as what? Self-adjusting force. If you remember the last year's topic. Okay. So like this, forces generally occur in pair only. Single force never occurs. Single force never occurs. Single force never occurs. Okay. Even the single resultant may occur. Resultant may occur, but a single force will never occur. Okay, that is what you have to remember. Whether it is a body at rest or the body which is performing a circular motion. So once you say that an object is performing a circular motion, what are the forces that exist are? That is, one is centripetal force, which is nothing but the force which acts toward the center of the circle is called as the centripetal force, and the force which acts away from the center of the circle is called as centrifugal force. And centrifugal force is always equal in magnitude to the centripetal force, but opposite in direction to the centripetal force. Okay, direction of the centrifugal force is exactly opposite in direction to the direction of the centripetal force. So this you have to remember as long as you study rotatory motion or circular motion or gravitation. Okay, so what is about the centrifugal force? Right. Then coming to the power topic. So here, what did we discuss? So one is centrifugal force. So if you have reference, this is centripetal force you are saying, no? That's all. This is centrifugal force. So it is Fc only. We indicate both the centripetal and centrifugal force Fc only. So Fc. Fc is minus. That's all. Okay. Because the minus means here the direction is in the opposite of to that of the centripetal force. So this is the reason. So centrifugal right. Why I say that centrifugal force is a pseudo force means actually it is depending on the centripetal force. So what should you understand? If the centripetal force is present, only centrifugal force will be there. Singly, centrifugal force will not be existing. Okay. So that's why we are saying centrifugal force does not exist independently. Means what? If centripetal force is present, then only this will come into existence. Otherwise, no. Otherwise, no. Okay. So you can how can you understand this one means? Okay. So only first centripetal force has to be present, and then only the centrifugal force is existing. Right. So what is the form of what centripetal action? So it is given by v square by r, where v is equal to velocity of the object performing, and r is the radius of the circle. Radius of the circle. Circle means circular path here. Then Fc, centripetal force. Okay, is given as generally ma, no. Okay, but a is what here? M into v square by r. So therefore, centripetal force is given as m v square by. So it is given as m v square by r. So this is our definition or formula for centripetal force. So the next topic is regarding the universal law of gravity. What is the amount of gravitational force? Okay, which is acting on two objects when they are separated with a particular distance apart. Okay, let us see that. Right. So here, if two objects of particular mass m1 and m2, okay, two objects of masses m1 and m2 are present at a particular distance d apart. Okay. The two objects are masses m and m, or otherwise m1, m2, or otherwise m and m. Okay, are present at a particular distance. So this is the centers. These are the centers, and the distance we have to calculate. So this is the distance between them. Okay. Now the force of attraction between two objects is given as, okay, force now is, okay, the force among these two is directly proportional to, okay, there is products m1 and m2, okay, or F is directly proportional to m into m, and then it is inversely proportional. Okay, it is inversely proportional to the square of the distance between them. If you think it is d, you can write d, or 1 by r square. R again here distance only. Distance only. So this is not necessary. Unnecessarily you may confuse because r means you may confuse like radius. Okay, not necessary. So it is directly proportional to the product of their masses, and it is inversely proportional to the square of the distance between them. It is inversely proportional to what? Square of the distance between those particular two masses. Okay. So now we combine these two. So what you will get is F is proportional, directly proportional to m and m, and inversely proportional to 1 by d square. So we combine these two, we get, okay. So F is proportional to m and m, or m square, m into m by d square. So to remove this proportionality constant, so what we have to do? Suppose imagine this is a 1 kg object. This is a 1 kg, and this is also 1 kg, and the distance between them is 1 meter. And the distance between them is 1 meter. Then the force acting on them is given as, so F is equal to, okay, K m into m by, okay, d square. Now here, what is the value of k? Okay, as we are defining here, d is 1 kg mass and 1 kg. Okay, both are 1 kg mass. So therefore, when k equal to 1, because we are defining r in unity, unit force we are defining. So here, when k equal to 1 means here, then what will remain? So when k equal to 1, what will remain? So why k equal to 1? You may ask me. Why k equal to 1 means we are defining the force of all the things here, physical quantities, in 1 unit. So here, see, mass, first mass. 1 unit mass means what is the SI unit of mass? Kilogram. Kilogram. So another mass, kilogram. So distance, 1 meter. Okay. So when these are all 1, this entire thing becomes 1. This total becomes 1 Newton. Okay. So in that manner, okay, if these are not 1 kg, then if k is equal to 1, because it is constant. Okay, this is constant. What do we say is, okay, so when k equal to 1, F is equal to m1 m2 by d square. That's all. This constant is represented with another alphabet, that is, what is that one is? F is equal to g m by d square, where g is equal to universal gravitational universal gravitational constant. So let us try to get the unit of this capital G. So if we want to get the formula for G from this one now, okay. So what do we write? G m equal to F into D square. So just keep G here. So if you keep only G here, so that is given as F D square by m into m. So what is the SI unit for force? Newton. Newton. D square means distance square means distance into distance. What is the SI unit of distance? Meter. So D square means meter into meter. Meter square means square. Meter into meter. Meter square. Meter square. And mass into mass here. Kg into kg. Kg square. As it is in the denominator, we write it as kg power minus 2. Kg power minus 2. So, what is the unit of universal gravitation constant? Universal gravitation constant symbol is capital G and the unit is Newton meter square per kg square. Newton meter square per kg square. Then value is G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, per kg square. So this is the value of universal gravitational constant. And what is this? This is the law of universal gravitation. Universal law of gravitation. So what is this law? This law itself is what is given by Newton. That is universal law of gravitation. Universal law of gravitation. Universal law of gravitation is represented like this. So, state the universal law of gravitation means what you have to say. What will you say is universal law of gravitation states that the force of attraction between any two masses is directly proportional to their product of the masses and inversely proportional to the square of the distance between them. Okay. So, if I have to write it in the form of a law, okay, sentence. Okay, I'll write it in the sentence. So, you understood this one? Okay, this is not necessary. I'll write in this place. So, universal law of gravitation states that when two bodies of masses m1 and m2 are separated by a distance d apart, then the force of attraction between them is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, right. So, I'll write this. Universal law of gravitation. So, in the sentence form, if you have to write, so what will you write? What will you write is when two objects, will start with the force of attraction. The force of attraction between any two objects of different masses m1 and m2 of masses. M1 and M2 separated by a distance d. is given as E. So E is directly proportional to E is directly proportional to the product of the masses product of the masses and inversely proportional to the square of the distance between them. So this is the statement form of universal law of gravitation, but concept wise it is easy. So what is the concept? What you have to understand is here, if two objects are same mass or different, whatever the masses may be, so the M1 and M2 suppose, and they are at a particular distance, every time we not to 1 meter, and this mass will be 1 kg. That means the objects here, what they are speaking, that could be anything. The entire, that means the Earth and the Sun, Earth and the Moon, Moon and some other planet, or Earth and some other planet. So whatever, okay, Sun and other star. So this is applicable to all the objects in the universe. Any two objects in the universe. That's why it is called as what? Universal law of gravitation. It is not Earth law of gravitation or Sun law of gravitation or other thing. It is universal law of gravitation, which means that it is applicable to any two objects. Suppose even this, what is this one? Marker pen and the Earth also. Okay. So whatever the object could be, if that object is possessing mass and it is occupying certain volume or whatever, okay. So this law is applicable. This law is applicable. Okay. So that means here what can you understand? If the distance is increasing, then the force of attraction will be decreasing. Okay. So the force of attraction will be decreasing as the distance increases. So that is understood. So here any two objects of particular masses, okay, are separated by a distance d, then the force of attraction between, what does the universal law of gravitation say? It gives us the magnitude of the force among any two objects that are separated by a particular distance. Okay. So what does the universal law of gravitation say? So what does it tell us? What does it tell us? It tells us the magnitude of, that means how much, see, F is equal to g mm by d square. So this means what? How much? So it is telling us about how much force of attraction is present among any two objects of masses m1 and m2 separated by some particular distance d. So for this, okay, this was actually given by Newton, but the research, the entire research was done by Galileo. That's why Newton already said, after formulating or giving this formula, what he said is, I am standing on the shoulders of Galileo or my ancestors, he said. That means the knowledge or the research information given by different scientists, Newton utilized the information and with his own knowledge, okay, he formulated this one, which was proved scientifically correct. Which was proved scientifically correct. That's why only we are learning this one. That's why only we are learning this formula. Okay. Okay, students. So once again, I repeat this. So what is the information? What does the universal law of gravitation tell us? It is giving us the information regarding the magnitude of force of attraction between any two objects of masses m1 and m2 or any mass separated by a particular distance d. Okay. So read the law. The force of attraction between any two objects of masses m1 and m2 separated by a distance d is directly proportional to the product of their masses. So directly proportional to the product of their masses. That way it is m square also. No problem. Okay. So m square also. Now and what is that? And inversely proportional to the square of the distance between them. Inversely proportional to the square of the distance between them. So it is inversely proportional to the square of the distance between them. So directly proportional to the product of their masses, inversely proportional to the square of the distance between them. Same we have even the other types of forces also, electromagnetic. That means if two charges, suppose if you think is two charges, charges q1 and q2 separated by a distance d. Okay. So what is the force, electrostatic force of attraction between them is, so how do you give it is, so F is equal to q1, that means it is again same Coulombic force of, or what we call that is Coulomb's law of electrostatic attraction, Coulomb's law. So that was given by Coulomb. So that is directly proportional to the product of the charges. So under so it is given by 1 by 4 pi epsilon naught u1 u2 by d square. Here this is the constant here, so we call it as dielectric constant K. Okay, and here epsilon naught is called as the permeability of free space. Okay, sorry, permittivity of the free space. Similarly, for magnetism, in magnetism also it will be there. If this is one pole and this is another pole, suppose north to south, south to south, whatever. So that also is given as F is equal to, okay, mu naught by 4 pi, into m1 into m2 by d square. Here this is a constant here. So this is a constant here. This is a constant. So we call this as okay, epsilon naught. Where epsilon naught equal to permittivity of free space. And here mu naught is the permeability of this permeability of free space. So here like that you can generalize, okay, all the other kinds of forces also. Here m1 and m2 are magnetic dipole moment, we will say magnetic dipole moment. So dipole moment is a different concept. So when we study about magnetism, I will explain that. Okay. So we can generalize. So why I am saying that is, so you can generalize this like this. Okay. So this is Coulombic force of attraction. And here we need to judge two masses here, two charges here we are studying, and here are two dipoles, two poles of different pole strength. Okay. So when we study magnetism, and this force of attraction is common. Okay, common. So charges q1 and q2 by d square. Dipole, magnetic dipole moments m1 and m2 by d square. But the constant is always present. Okay. So here we call it 1 by 4 pi epsilon naught. In 1 by 4 pi epsilon naught we call it as permittivity of free space. That means the permittivity of electric charges. And then this is mu naught by 4 pi. So that is mu naught is permeability, magnetic permeability we will call. So that like that we have these generalized forms of this force of attraction. Okay, this we will study later. And now let us draw the relationship between, okay, this what is the acceleration due to gravity and this force of attraction. So I will draw this one dot by. Let us try to draw the relationship between acceleration due to gravity and universal law of gravitational force. Okay. So actually here, if you remember the Newton's second law, what does it say? Okay, rate of change of velocity is directly proportional to the force acting on it. That means F is equal to ma. Simply to say, yes or no? Right. So if the force of, okay, if the second law, Newton's second law of motion, this is universal law of gravitation. So Newton's second law of motion. If you remember, you can draw another relation between this. Okay. So what does the Newton's second law of motion say? F is equal to ma. So a equal to g. Acceleration due to gravity. So that means here F is equal to mg we can write. So the same is the force here. F is equal to gmm by d square. No? Okay. So let us apply this here. Mg. So this m f and f forces. Force of attraction only, no? So both are forces only. So mg equal to g capital M into small m by d square. Okay, if you write this, that means you may get a doubt. That means you may get a doubt that is this acceleration due to gravity or this force of attraction between one object and another object? Is it depending on the size? Is it depending on the size of the object for that we will get a relation here now. Okay. Now can we cancel this small m and small m? Okay, as these are the lower less masses. So finally G can be given as V into m by d square, where m is the mass of the f, and small m is the mass of any object. That means finally this is the relation between acceleration due to gravity and the universal law of gravitation. That means here any object irrespective of the mass is attracted towards the earth with the same value, that is 9.8 meter per second square. That means suppose for example, a ball is thrown from particular height and an aeroplane flying at a particular height, some 200, 300 feet or some 500 feet something, suppose you think. Okay, suppose if the engine fails in the aeroplane, it is also attracted towards the earth with the same force or with the same value of g what a small ball is being attracted towards the earth if air is not present. This is the condition here. Okay, so here this was told by Galileo. So how did he do this? Means he took two vessels like this. No, not this one. Big what to say that one? Cylinders. Okay, big cylinders like that. Big cylinders. He evacuated air from that one. Both the cylinders. He evacuated the air and he dropped one iron ball in one of the cylinder and a feather of a bird in another cylinder. Then he observed. So what did he find? The result was amazing, mind-blowing, that changed the entire subject from then. So what did he finalize this? They both came down in a same time. That means if air resistance is not present, actually in the real time situation it is impossible. Okay, to remove air from a container, okay, little bit it is possible. Evacuation pump will be there. With the help of the evacuation pump, we can remove the air. It works exactly opposite to the mechanism of the motor. Okay, exactly opposite to the mechanism of the motor, evacuation pump. So it will remove all the air from the particular tumbler, whatever it is. So he did that one. So finally, what did he find is any object is attracted towards the earth with the same value of g. Okay, if air resistance is absent, but we cannot remove the air from the earth now. Okay, but it is true. Because this will be seen when you go into the space. Okay, what happens is there you will feel weightlessness. What is weightlessness? Okay, that is another topic. Okay, time is up. So we discuss the remaining topics in the next class tomorrow. So right now, okay, let us revise this one. So finally we will end this up. So the relation between acceleration due to gravity and universal law of gravitation and the force of attraction between any two objects according to universal law of gravitation. Okay, the relation between acceleration due to gravity and the force of attraction between any two objects according to universal law of gravitation, or simply to say the relation between G and G. this capital G and small g. Capital G and small g. What can we say is, so from the Newton's second law of motion, we have already F is equal to ma, which is the force acting on that object if it is accelerating. Then here also we have one another formula. So if we see the relation between G and G, so as the forces are equal, we equate these two. And mass, this is the mass of some small object when compared to the mass of the Earth. But here m is the mass of the Earth we are taking. Okay, how to Earth? Yes or no? That only we want to know. So cancel m and m. So what is meaning? G is equal to dm by d square. So it is evident that any object is independent of its mass is attracted towards the Earth with the same value of g, small g, that is 9.8 meter per second square. Okay, students. So this is our topic. Hope you have understood. Okay, have a good day.